Web services allow two computers to communicate and exchange data, and I use the term computer loosely. You can have smartphones communicate with web servers, or have web servers communicate with a mainframe, but for many years when someone talked about web services, you generally assumed they were talking about SOAP, SOAP-based web services. If you've never heard of SOAP, that's okay. It's not important to know what it is for this module, but generally speaking, .NET developers have been using Windows Communication Foundation, or WCF, to implement SOAP-based web services over the last few years. And one of the goals of WCF was to abstract away the underlying transport technology used to exchange messages in a web service transaction. WCF and the SOAP specification didn't want you to know if you were using HTTP or MSMQ or sending binary data over TCP sockets. But over the last few years, some web service implementations have been moving away from SOAP and that transport agnosticism, and instead building web services that embrace HTTP. Because it turns out HTTP is a flexible protocol that works very well on the internet, where most of us communicate. HTTP messages can be cached, they can travel through firewalls, they're lightweight, they can be processed by processors on mobile devices, they can be encrypted, and best of all, nearly every programming environment in the world offers some capability to send and receive HTTP messages. SOAP-based web services generally required a toolkit and more processing power. HTTP is everywhere, it's lightweight, and you can use it to exchange information with big servers as well as small devices like mobile phones. So faced with this shift in web services, the Windows Communication Foundation team at Microsoft began working on a new framework that is now a part of ASP.NET and is called WebAPI. The idea is that WCF is still a great technology when you're writing enterprise services and can use toolkits, but the WebAPI is going to be more focused on being lightweight, highly interoperable, and using HTTP all the way. Now we know that the WebAPI is a framework for building web services on top of HTTP. And WebAPI is going to allow us to easily consume XML or JSON. We're also going to see it's easy to produce XML or JSON. And one thing you're going to notice about it is that it has very similar features and concepts to ASP.NET MVC. There's controllers, there's models, there's action filters, but the MVC you are used to is really optimized for producing HTML by rendering a view. The WebAPI is optimized for working with every other content type, JSON, XML, anything custom that you want to plug in. It's also very extensible like MVC. You also get started a little bit differently with WebAPI, because whereas MVC is optimized for building web apps that run on a web server like IAS or IAS Express, WebAPI is designed to run anywhere, so you can start a new MVC project and make it a WebAPI project. That's one of the templates that you can select when you do File New Project. Or you can just start an MVC4 web application, a regular one, and WebAPI can be a part of it. Or another option is to start and have any kind of project, even a console mode program, and host a WebAPI inside. The easiest way to do this is to use NuGet to install Microsoft.ASP.NET.WebAPI.selfhost package. That will give you all the assemblies and framework support that you need. We're going to start off by building an ASP.NET MVC4 web application, just a regular web application like we have been working with, and see what we can do with the Web API inside of a web app. Here we are inside of Visual Studio, and I'm going to start a new ASP.NET MVC4 web application. The name of this project is going to be Videos, and let me go ahead and click OK, and what you'll see is that Web API is one of the project templates available in Visual Studio. If I click that, I get an ASP.NET MVC project with a Web API controller already installed. But let's go ahead and build just a regular ASP.NET MVC Internet application and add an API controller to this project once it gets spun up, because you can add Web API into anything. Now the new project is finally put together, and let me just hit Control F5 to make sure everything is running properly before we start making changes, and it looks like the home page appears properly. So now I'm ready to work with the Web API, and I can do that already because when you create a new MVC4 project, an internet application, it will provide you everything that you need to work with the Web API. Most notably, it will include the system.web.http assembly. And that is actually done by installing the Web API as a NuGet package. In fact, if I look at the list of installed packages in this project, it includes everything from jQuery to the entity framework to the Web API, which is over here on page 2. And this is actually a nice feature because currently I'm working with the Web API, the release candidate version. At some point, there will be an update to this package, and when there is, all I need to do is come into my NuGet packages, look at the updates that are available, click Update, and I'll be working with the latest version of the Web API. That's great, but I have everything in this project that I need to work with the Web API already, and what I'd like to do is build a little web service using the Web API that will allow someone to make calls to manage a list of videos, and that means responding to HTTP requests. And just like everything else in ASP.NET MVC, if you want to respond to an HTTP request, you need to write a controller. But in this case, my controller is going to be slightly different. I'll right-click on the controllers folder, say Add Controller. I'm going to call it a video controller. And the template I'm going to select is API controller. So not a regular MVC controller that can render views, but an API controller with empty read-write actions. And even though I'm adding this to the controllers folder, there's no reason that I have to do that. I could put it anywhere inside of this project. A lot of people like adding API controllers to an API folder, but you could also have them in the same folder as the other controllers or in a different project that's referenced by this web project. They can live anywhere. So with the controller name specified, the template specified, let me click Add. And one of the reasons this is called an API controller is because it's part of the Web API and it derives from a base class known as API controller. So this is the base class for all of the Web API controllers that need to respond to HTTP messages. API controller is going to be somewhat familiar to you if you've worked with MVC controllers in the past, because it still has a controller context property, it still has a model state property, you can get to the requests, you can get to the current user property. And you might think that if I did a build at this point, that I'd be able to reach this controller with a browser just by going to localhost/video/git, because that's the way the rest of MVC works. If I have a home controller with an index action, then I go to /home/index and it appears. But API controllers, the routing rules are slightly different, and that's what we're going to look at next. Even though I went to /video/git, I don't appear to be getting into this method. Instead, I'm getting a 404 error. So let's talk about routing with Web API. One of these significant differences in the Web API compared to traditional ASP.NET MVC controllers, one of the differences is how the Web API will route requests into the action methods. With the Web API, the HTTP method being used plays a role. The HTTP method is the verb used in the HTTP message, and the common verbs are get, post, put, and delete. Those are the verbs that the Web API will route by default. You can also handle additional verbs if you need to do something like WebDAV. You can do that and handle additional verbs by using an accept verbs attribute. What the Web API will do is if there is a request for /videos, the Web API will look for a video controller and then look for a method on that controller starting with the word get. So I could have an action called get videos, and because this is an HTTP GET message, the framework will invoke get videos. But I could also call it get whatever. It's just because it starts with the letters GET. That's why that particular action method will receive the request. The Web API also registers these routes slightly differently. Since there is no action that's going to be in the URL for the routing engine to pick apart, it's using the verb instead. If you look at the default route configuration in a new MVC application, and I'll show you where to find this in a minute, you'll see the default routing rule for a Web API. It's done with an extension method, map HTTP route. Notice there is no action in the URL template, and it's also important to note that the path for this needs to start with API. After looking at this, I know the proper way to reach my video controller is to use /API/video as a URL in the browser. That will invoke the get method since we have a get request. Let's try it out. So before we try to view the controller output in the browser again, let me go in and make one change to this controller. I'm going to do a refactor, rename, and change the name to videos controller, plural, because it's really going to represent a collection of videos, not a single video, so it makes more sense for it to be plural. And now, as far as the default routing rules, routing's always configured during application startup, so of course that means you have to look in global.asax.cs. Inside of there is the application start event, and here is the line of code that we'll call routeconfig.registerRoutes. Routeconfig is a class that is added to a project by default when you start a new MVC4 project. It goes into the app start directory. There's a number of things in here that configure the runtime during application startup, and if we look in routeconfig, indeed there's the map HTTP route extension method being called to set up the default routing for our WebAPI controllers. And now I know if I want to reach the videos controller, then I should do a build first and come into the browser, and instead of doing /video/get, I should be doing /API/videos. And now I do receive a response from the server. Internet Explorer doesn't want to show me that response, it wants me to save it or open it, and that's because it realizes that the server returned JSON. So I could open or save that, or I could use a different browser that would actually show me the result in the browser window. But I'm going to try a slightly different approach, which is to go to a command line utility called curl, or curl. This is a utility that allows you to send off web requests from the command line. So for instance, I could request localhost :1341, that's where the application lives, and it shows me all the HTML that would be rendered by the home page. And that also means I should be able to go to /API/videos, and by default, it sends a GET request. That invokes the GET action, and I can see value 1 and value 2. They're formatted into a JSON array, and that's exactly what I expected to receive back based on the code that's inside of the GET method. Let's actually run this with the debugger one. So let me put an F9 here on these two different GET actions, and while I'm at it, let me rename this to GET all videos, just to give it a different name. And I also want to put a breakpoint on the delete and see how this works. And now I'll do a build since I changed the action name, do an F5 to run it with the debugger. That'll launch it in the browser. But what I really want to do is come back to curl and say, let's issue that same request again, /API/videos. So it's just trying to map the HTTP verb to the method name, but it doesn't have to be an exact match. It just has to start with a GET. And now what about this other GET that includes an ID? And actually, let me stop debugging once. And actually, when we send a response back from here, I want to include the ID that we see in the response. And so I'll do a build and hit F5. And let's come back to curl. And by the way, with curl, you can use the capital X parameter to specify the method that you want to use. So I'll just make it explicit that this is a GET. And we'll try that out one more time. That arrives at this GET action. Hit F5 to continue. And let's try with an ID. So I want to get the video with an ID of 5. And notice that arrives at the GET method that takes an int parameter. So this is also something special when it comes to WebAPI, because the traditional MVC routing wouldn't distinguish between two methods that have essentially the same name that just differ by the method signature it would give up. But in the WebAPI case, you can have a GET that doesn't take any parameters and a GET that does take a parameter. It doesn't really matter that I rename this to all videos. It's really just looking for a method that starts with GET. But it's able to distinguish between those two because it does see an ID that arrived in the URL that got put into route data and got passed into us. So we can see the 5 come in. That should be very familiar if you've done MVC programming in the past. And if I hit F5 to continue, then we get value 5. This is working well. What happens if I try to delete the video with an ID of 5? Because I have a delete action in the background. Now I get back some sort of weird error message about the file or directory does not exist on the server. And that seems peculiar, and this is something that you might run into occasionally with the WebAPI. And the problem is that not all web servers allow all the HTTP methods to come through. So pretty much any web server is going to allow a GET or a POST because we all use them in day-to-day web programming with HTML. But not every web server is configured to allow a put or a delete. Those aren't as common. And that's what's happening in this case. This is running in IAS Express, which is a lightweight version of IAS that now ships with Visual Studio in 2012, and it's the default host for any web applications that you build. What I need to do is go into the configuration file for IAS Express. That configuration file lives in my Documents directory under a folder called IAS Express/config, and it's inside of there where I can find application host. And it just so happens that I know I'm looking for an entry in here called extensionless URL integrated 40. And right here we can see that the only verbs it's going to map to that particular handler are get, head, post, and debug. I also want to add put and delete, so we handle those verbs as well and allow them to pass through to our logic. I should just be able to save this, and then we can come back out to curl and try to delete the video with an ID of 5. And now that request arrived at our server. So inside of these action methods, what we would ostensibly be doing is working with a database or some sort of persistent data store or the file system to look up videos, create videos, in this case, delete a video. But before we get to that, I want to talk about another important feature of the WebAPI, which is content negotiation.